colonizing Mars would be humanity's greatest leap into space. But what would it take, and how would Mars change as a result? Before humans arrive, robots would prepare the ground, constructing habitats, mining ice for water, and generating oxygen from the Martian atmosphere. SpaceX and NASA plan to use in-situ resource utilization to produce fuel from Mars' CO2, ensuring long-term sustainability. The first settlers, scientists, and engineers would live in radiation-shielded habitats, relying on nuclear power and hydroponic farms. Underground tunnels or lava tubes might become permanent bases, protecting against cosmic rays and extreme cold. The challenge isn't just survival, it's building an economy that makes Mars self-sufficient. Human activity would reshape the Martian landscape in ways both predictable and unexpected. Mining operations would extract metals like iron, aluminum, and even rare minerals that are scarce on Earth. Harvesting water ice from craters and underground reservoirs would provide drinking water and fuel, but could also alter local geology. Over time, extensive excavation might change Mars's surface composition, releasing trapped gases and influencing atmospheric pressure, even if only slightly. Frequent spacecraft landings and surface rovers would kick up massive amounts of dust on a planet already plagued by global dust storms. Mars' thin atmosphere makes dust settle more slowly than on Earth, which could create long-term effects on climate patterns. Some scientists predict that human presence could trigger microclimatic changes in localized areas, potentially melting small ice patches and creating transient liquid water. Another major concern is biological contamination. Even with strict sterilization protocols, Earth microbes could hitch a ride to Mars and find niches to survive in, such as subsurface ice pockets. If they adapted to the harsh conditions, they could interfere with future efforts to detect native Martian life, or in extreme scenarios, alter the planet's ecosystem before we fully understand it. Terraforming efforts, though still theoretical, could begin with greenhouse gas production to raise temperatures. One idea is releasing gases like methane or perfluorocarbons to trap heat, mimicking Earth's greenhouse effect. Some scientists propose using genetically modified cyanobacteria to slowly convert CO2 into oxygen. While full terraforming would take centuries or even millennia, these small interventions could gradually make surface conditions more manageable, allowing future generations to live with less dependence on artificial habitats. A Mars colony would shift civilization's focus outward. It would act as a lifeboat for humanity, ensuring survival beyond Earth. Technological advances from space habitats, better radiation shielding, AI-driven automation, closed-loop life support could revolutionize life on Earth. Beyond Mars, colonization would pave the way for asteroid mining, moon bases, and deep space exploration. A successful Martian foothold might be the first step toward interstellar travel, pushing us beyond the solar system. Mars won't just be a colony, it will be the beginning of a new era.